Hai, Assalamualaikum warahmatullahi wabarakatuh. Welcome back to Miss Rini's class. Today, let's learn about equilibrium constant. We will continue our discussion about the equilibrium constant of concentration and equilibrium constant of pressure. So that let's start our lesson by reciting basmalah together. Bismillahirrahmanirrahim. All right, I'm going to share screen. Okay, so here, equilibrium constant calculation. Uh, I show you sample question. So from this sample question, we will implement how to use this formula. So if you see here, we have the formula that can relate the constant of equilibrium in terms of pressure and constant of equilibrium in terms of concentration. So the formula that will we use is Kp equals to Kc multiplied by R times T to the power of delta M. Okay, so let's solve this question. The equilibrium concentration for the reaction between carbon monoxide and molecular chloride to form COCl2 gas at 74 degrees Celsius are concentration of CO equals to 0.012 molar and the concentration of Cl2 equals to 0.054 molar and the concentration of COCl2 equals to 0.14 molar. The question is, calculate the equilibrium constant Kc and Kp. This is the reaction. CO plus Cl2 equals to, or it will produce COCl2. And then from this question, we have the concentration of all substance in this reaction. We can use this information to find Kc because Kc formula is needed the concentration of all substance involved in this reaction. It should start from the product to the power of the coefficient. Since the coefficient is 1, so there's nothing here. So yes, COCl2 first because it is the product divided by CO times the concentration of Cl2. And then just substitute the number and we got the result of Kc directly here. So 220 mole per liter is the Kc result, the Kc data. By using this formula, we can get the Kp. So even if we don't know the pressure, we still can get the Kp using this formula. So substitute the Kc that we have already, and then this is the data of R. This is the constants of gas. And then T is the temperatures we can see here from the question, but it's still in Celsius. We should convert into Kelvin. So add with 273. And for delta n is the delta of coefficient. So we should find the coefficient once again. It starts from the product minus the reactant. So here 1 minus 2 because it is 1 plus 1. So the final result is minus 1. Next, we substitute the data. Delta n is here, and then Kc is here, and then R and T, and then by calculator we can get the result that is 7.7 atmosphere. So this is the final unit for Kp. That's it. So it is easy to find Kc and Kp if we know this formula that is the relation between that two terms. How is it, everyone? Do you understand? All right, it's your turn to practice now. I show you the next problem. So here from this case, we can see the question asking about Kp and Kc the same, but the difference is we know the pressure. We know the pressure of each substance here. So how to solve this problem? Do you have any idea? Now it's your turn to practice. Everyone find the answer and please send your answer to me directly. As a clue, I'm going to show you how to solve it. We can find the KP first. So that's the difference between the previous one and then do a little changes of the formula. Switch the formula and then you can get the KC from the KP. Okay, hopefully you can do it. But if you still face the difficulties, you can ask me directly. And then, yes, I think that's for today's session, everyone. Let's close with saying Hamdallah together. Alhamdulillah, Rabbil Alamin. All right, see you on our next class, everyone. Assalamualaikum warahmatullahi wabarakatuh.